So the quiz today, I gave a question about symports and antiports. And the question stated that magnesium was co-transported with molecule X, and that you had to design an experiment to determine, is it a symport or an antiport? So the important thing to do here is to start with the definition. So symport, all of you so far have been able to tell me with a symport, the molecules are moving in the same direction. And one of these molecules is going to be magnesium, and the other one is going to be molecule X. But here's the thing. One of these molecules, because these are symports and antiports are co-transports, they are being used for active transport. And the way that they're doing it is that one molecule is moving from high concentration to low concentration, and that's helping it move the other from low to high. So in this case, magnesium is moving from high to low, and that's so that molecule X can move from low to high using that energy. So now let's go to the antiport. And antiports, remember, they move things in the opposite direction. Okay. Now, our magnesium is still supplying the energy for the molecule X to move, so magnesium is still going from high to low, and molecule X is still going from low to high. So I gave an example of this today, and I said, you know what, if my son and I were at the park, and he didn't want to climb the stairs to get up to the slide, and I was at the top of the slide, if you tied a rope around my waist and a rope around his waist, as I go down, he would get pulled up. So I'm going from high to low, and he would be going from low to high using the energy given to him by me. So this is an example of sort of like an antiport. All right. Now, with this scenario where you're supposed to design an experiment, how in the world do you do that, right? Well, you know the definitions, you know how things are moving. So now all you have to think of is if I were to have a beaker that had a membrane in it, and that membrane's got channels in it, all I have to do is adjust my concentrations. If I've got high molecule X on this side and high magnesium on this side, magnesium's going to go high to low. If it gives the energy for molecule X to go low to high, then we'll see movement. If it doesn't, then we could try the alternative experiment. And in the alternative experiment, now I put low magnesium on this side, and if we get movement, we know that it's a symport. So I hope that this has given a little bit more clarification. And this question was one that I previously used on an exam. My goal is to get you to express your understanding of symports and antiports, and the key here is that one molecule is moving from high to low because it's supplying the energy for the other one to move. So it's not necessarily that they're moving in the same direction or opposite directions. It's what all of that means with this idea of active transport.